Okay, let's go ahead and get started. Thanks for joining us. Welcome. I'm Sam Moyer. I'm a research fellow at NDIA's Emerging Technologies Institute. Thanks for joining us today for the webinar, Mission Critical Connectivity, Satellite Solutions for Defense Applications. Today, we're going to be discussing the applications of commercial SATCOM solutions for defense missions with a focus on the narrowband. Couple admin items before we get started. All attendee lines are muted today, so you will only be able to communicate with us via the Q&A feature. If you have questions throughout the webinar, we encourage you to ask them, so please go ahead and use that Q&A feature, and the panel will get to them at the end of the panel. You can submit questions throughout the webinar, so please go ahead and do that. I also wanted to note that we will be recording today's webinar for those unable to attend live. So with that, I'll hand things over to Arnie Strayland for some welcoming remarks. Arnie is the chair of NDIA's Space Division, and he's a corporate lead executive at Northrop Grumman Corporation. And Arnie has many decades of experience in the national security space sector. So Arnie, over to you.
Hey, thanks, Sam. And on behalf of NDIA Space Division, we're pleased to support the Emerging Technologies Institute and this important discussion today. The value of commercial SATCOM for how the Department of Defense executes what really is the data-driven American way of war fighting is absolutely essential to mission success just across every spectrum of conflict. And so this discussion today is important to inform that conversation. How can our government customers leverage commercial capabilities in addition to their purpose-built systems to really enable mission success? So we're excited to have this, to support this discussion today. Look forward to a valuable discussion and good Q&A afterwards to help inform this important discussion about delivering a mission critical capability. Thank you.
Hello, folks. My name's Henry Orwela. Welcome to this webinar. Just by way of introduction, I lead the Government and Defense Development team at Globalstar. Thanks again for attending today. I'll be moderating a bit, but before we do that, I want to kind of kick this webinar off with a few words really focused on what the Department of Defense, what their growing interest is in terms of commercial satellite services. As Arnie said, most folks likely know the traditional DoD model for satellite services was to invest in building and deploying military satellite assets. However, in recent years, the policy really has transitioned from buy versus build mentality. Buy if you must, buy if you can, build if you must. And that's been really the key guiding philosophy for the U.S. Space Force acquisition strategy. And a sign of this really is in 2024, they actually increased their primary commercial satellite services contract. They increased the ceiling from $900 million to $13 billion last year. So that's a good sign that this is really a big shift for the Space Force. And one of the primary drivers for that transition is that things like cost effectiveness, speed of service, commercial satellite service providers, they innovate rapidly. Also, it provides resilience to existing military assets and also gives them a lot of operational flexibility. And so for those not familiar with Globalstar, we have actually been a commercial provider of satellite services for over 30 years. We own and operate our own 24 satellite low Earth orbit constellation, providing mobile satellite services globally. So the MSS services are narrowband, and which means our solutions can support hundreds of thousands of simultaneous users within regions or countries, and provides a reliability of service that terrestrial and cellular communications, if they're down, we can still operate and provide service globally. The other aspect of our system is the devices that we use across the network. They're characterized by very, very low size, weight, and power and cost, which also gives the military some advantages in terms of applications. And so the Globalstar background, it's important because while most people associate DoD's interest in commercial satellite to broadband, there's actually equal interest in leveraging narrowband satellite services. And so as such, we at Globalstar have been actively engaging the DoD mission stakeholders to try to understand their interests and the applications for these types of services. So today, we're really going to focus on the mission critical nature of narrowband satellite comms, the applications, the technology, and the capabilities that enable our military. That said, I'd like to introduce our panel today. We're honored to have Major General Gino Dell'Oracco, U.S. Army retired. He served over 35 years in the United States Army. He served in various tactical R&D, test, human capital, and program management, coupled with strategic planning assignments. His career culminated with 3 high-profile positions as the Deputy Commanding General, U.S. Army Research and Development Command at Fort Belvoir, Virginia, the Program Executive Officer for Missiles and Space at Redstone Arsenal, and the Commanding General of the U.S. Army Test and Evaluation Command at Aberdeen Proving Grounds. Since official retirement, Gino has continued to serve and consult in various roles within to support the Department of Defense. So welcome, Gino. Thanks for joining us. And then we've also got Marty Jefferson. He currently serves as the Global Solutions Architect for Globalstar, with over 30 years of experience as an experienced senior technical executive. Marty helps drive the satellite IoT business for the company for both commercial and the defense markets. Welcome, Marty. Thanks for joining us.
Thanks, Henry.
So just to kick things off with the panel a bit, let me just ask a first kickoff question here. Maybe Marty, you can start. What is the current and potential role of narrowband commercial SATCOM for defense capabilities?
Well, thanks for the question, Henry. I think it really can touch many, many different areas. And what we're seeing in the space so far is that many of the things that we've been working on in the commercial space over the years really extrapolate well over into the defense market. Primarily, if you think about the things like logistics, tracking assets, having asset visibility, looking at things like maintenance of assets and things like that, getting visibility and getting a window to what's going on in the machines that are part of your day-to-day operation, and also the equipment that you rely on to carry out any sort of operation. We're also seeing some very creative uses of the commercial IoT space right now in some of the UAV spaces, particularly the single-use devices that we hear a lot about and see a lot of YouTube videos about these days. And what the reason for that is obviously things are quite inexpensive from a technology perspective. They are resilient to interference because in many cases they have no receivers. It's hard to spoof. It's things that get through some of the forms of electronic warfare that are obviously in place in many conflict zones. And what tends to drive innovation in these spaces is obviously, simplicity of the product, the fact that it just works, and the fact that on the Globalstar network, obviously we use some technology called bent pipe. And most of the brains of that network means that it resides on the ground stations, which are usually located outside of the conflict zones. So from a general statement perspective, we're taking some of the very simple solutions that have been used, for decades in the commercial space, extrapolating that over into the defense space, and we're seeing a lot of reemergence of use cases applied slightly differently, but still generating the same effect, giving you asset visibility, giving you usage statistics, giving you maintenance statistics, things like pressure, flow, temperature, things that are all part of the machines that are being used in the field, and also bringing in some sensor connectivity, right? So autonomous seems to be the word of the future these days. And if you can bring in a very simple autonomous sensor device that is monitoring virtually everything from motion to chemicals to anything that could be used in that sort of in that sort of environment, you bring in that connectivity. You can run it on simple batteries or simple solar panels, and it gives you the ability to deploy like never before without necessarily putting people or humans in harm's way. Oh, you're on mute, Henry.
I should just stay off
Thank
on
you.
mute. So yeah, so that's great, Marty. That some really good insight. I'd like to kind of hear from you, Gino, just in terms of the defense side of this. Like, you know, what's the interest from the mission stakeholders out there, and who are those mission stakeholders?
Well, it's basically anybody that has communications equipment. What Globalstar, well, what satellite narrowband has to offer is uh, an alternate means for communication. And it's all about surviving the battlefield at this point. If you can be seen or jammed, um, well, if you're seen, your survivability rate is goes down quite a bit. And that includes the RF signal. Either if you're receiving or emitting, and that's a pretty sporty way to run a combat operation. So we've got to think of other ways to do business on the battlefield in order to survive and to accomplish the mission that you're intending to do. Uh, One-way drones are key to a lot of the new type of warfare, but so is electronic warfare. And the attempt is to interdict the signals that are emitting through, GPS and other signals in such a way that they'll disrupt the effectiveness of that weapon system. So there's a lot of interest in keeping our weapon systems that are currently tactical and strategic in nature uh, immune to the electronic attacks uh, and be able to perform their mission. And part of that is going from broadband to narrowband, or in certain circumstances where it's narrowband is very hard to detect. Its low power weight ratio is really applicable to adapting to a lot of things that we currently have, or integrating them into the system as an alternative means of communication from that standpoint. I've got a little bit more later, Henry. I'll just back to you.
Yeah, that's perfect. Thanks, Gino. Just to tee up the next one here. So what are some examples of progress and successes in demonstration and adoption?
That one for me?
Yep.
Yeah,
Yep.
okay. Sure. Well, I would say over the last year, we've been involved and kind of conducted a whole and supported a whole range of different demonstrations with defense and government partners through very lots of different applications of the IoT space. Under CREDA, we with the U.S. Army, Globalstar is evaluating satellite-enabled edge processing. So obviously, when you're talking about narrowband, you're talking about a small pipe, and the amount of data that can go over the pipe necessitates some more onboard intelligence, like doing computing at the edge, where you're analyzing significant amount of data, and you're only necessarily reporting those actionable data items over the network. And it gives you that ability to take advantage of the power of computing nowadays, and to deal with narrowband networks that are in place there for you to use. This includes things like UAVs, as we talked about before, but also includes kind of vast sensor arrays that are monitoring various different environmental conditions, air quality conditions, things like that, analyzing those in a mobile environment, and really only reporting those pieces of information that are really important. I think it's important to to know that the place of narrowband is really to transmit data that is actionable. We live in a big data world now where the more and more data comes in, and it becomes a processing problem, both from the human mind and from a computing perspective. Big data is great, but it does burden the people in the field, particularly big data in the field, does burden people with analyzing that data and making decisions based on that data. We like to try and download as much of that processing into the field and report more selectively, I would say, to be able to get that data across a narrowband network, and in a way that allows the people that are concentrating on much more important decisions rather than data analytics to be able to get that actionable data. We work successfully with many partners, Parsons being one of them, Parsons Corporation. We did successfully integrating the LEO network into a software-defined communications platform, and that's providing a secure and resilient operation across multiple ground stations in the European region. And we've been working, very closely with manufacturers, OEM manufacturers on the UAV side of things, both overseas and domestically, to bring in this narrowband connectivity that is resilient to interference, that gives you the ability, because even in our world right now, even we have one-way solutions, we have two-way solutions, but even on the two-way side of things, the two sides of the equation act very differently and independently of each other. The receiver is not driving the transmitter, so they're half duplex in nature, which allows us to ignore certain things that might be getting into the device from a spoofing perspective, and also from a registration and device operation perspective. The Globalstar network brains reside on the ground, right? The satellites are mirrors in the sky, and they basically pass the data from point A to point B. And all of the validation, subscription information, data endpoints, everything resides on the ground, which gives us the ability to host that outside of conflict zones, and also to have access to adding additional features, bandwidth, hosted payloads, things like that. We're quite unique in the space to be able to do that kind of thing, because our brains reside on the ground.
All right. Thanks, Marty. And Gina, do you want to kind of chime in and give some context to this in terms of the Department of Defense?
Sure. It was fortuitous that last night I received a heads up from a colleague of mine that the 4th Infantry Division out of Fort Carson is going through a planning effort here with the Joint Modernization Command for Project Convergence 6. That's cuts across all, from a joint perspective, so cuts across all military services and the Fourth Estate in the Department of War. The key thing that they're starting to plan is for the next Project Convergence to test out technologies, integrated technologies in systems and with soldiers, but from a joint perspective, includes elements as appropriate from the Air Force and Navy for that particular technology demonstration. And why the 4th Infantry Division? The 4th Infantry Division is headed up by Major General Ellis. So Major General Ellis just left this summer from Aberdeen Proving Ground. He was the director for the network cross-functional team. He is leading the charge, if you will, on it now as a CG, Commanding General for 4th Infantry Division, to transform that division and transform technologies and the capabilities rapidly, so he can deploy his soldiers into his forces into the next event in this military historical environment we're now living in. And it's based on lessons learned from the Middle East, from Eastern Europe. There's a lot of things that we have to catch up on, and he's going to be leading the forefront on technology adaptation, and narrowband satellite communications linkages is going to be a factor in there, a very positive one. Over. Back to you.
All right. Thank you. Thanks for the context as well. So, we thought it would make sense in the panel to just talk in a little bit of detail around what are some of these types of devices, right, that support these applications. So, this is to you, Marty. Can you kind of get into and describe some of those devices? Also, just kind of reiterate some of the use cases as it applies to those devices, and maybe the features that the defense are particularly interested in with these devices. Does that make sense?
Sure thing, Henry. Not a
Yeah.
problem. So Globalstar operates kind of two different segments of user gear, so to speak. So we have a finished product section. When I say finished product, it's something that's a self-contained, self-powered, autonomous device that is generally used in the asset tracking space initially. But we've expanded kind of the feature set that's in that product to not only be able to give you asset location, but also tie into asset telemetry. So a lot of things have machinery on them, a lot of them have data points on them. So we not only can tell you where something is, we can tell you things like high oil pressure, low tire pressure. We can give you load, tilt, angles, G forces, things like that that are really accessories within the device itself. And these all tell you, whether you've got vehicles rolling over, whether you've got vehicles that are healthy in condition. And then just going right back to the basics of monitoring things like, how much fuel is on board, how much liquid is on board, how much whatever you're transporting, how much of everything that is on board. These devices are simple, very, very simple battery operated or solar powered devices. And we're taking the power of some of the other connectivity technologies locally, like Bluetooth, which can be secured quite significantly with the elliptical curve that we use on the device from an encryption perspective. And you can get very short range sensor information from all kinds of different applications. If you were to pick some just to highlight, think about status monitoring of everything from a piece of machinery, whatever machinery you're operating on, whether it's operating, effectively, and this can include speed and heading and things like that. Or think about something a little more autonomous, where you've got a BLE sensor, a motion sensor, a gas detection sensor that is deployed in the battlefield and requires some path, some modem in a box, so to speak, to get that data back to a command structure. And that's what the power of that Bluetooth interface does, and the power of the device itself. It gives you the ability to rapidly deploy something that doesn't require its own power source. It is autonomous. It'll operate. It'll send what it receives, and again gives you that access to have more autonomous devices in the field that gather information without putting people in harm's way. Then we have an entirely different division of Globalstar, which really concentrates all the way down to the actual chipset itself. So at the core of all of our products is a core chipset or a core ASIC that supports the Globalstar waveform. And we've developed that technology over the years to kind of where we are today with our STX3, which is still our tried and true single transmitter device. It's a very simple device. It runs on microvolts when it's not operating, and millivolts when it is operating. So it really supports battery operated applications and applications where small size, it's about the size of a US quarter ballpark from a perspective, that requires data to simply come through reliably. And because there is no receiver on the device, it is impossible to spoof the information. The information is being fed directly locally via a serial port on the device, and that can be encrypted data that's pre-encrypted before it goes into the device itself, and then literally is sent in its raw format over the air, and at the other end somebody needs to be able to decode that data, and it's a very small packet of data that goes over the air randomly at very, very short intervals, less than a second at a time at random intervals. So it's very hard to get a hold of that data, first of all, and if you manage to get a hold of that data, what to do with the data, because it's encoded on the way in and it's decoded on the way out. There's nothing actually done over the air. we built a little bit more intelligence into our latest chipset product or module product, the RM200. And where this has become interesting is there's a bit of a convergence of technology, and I'll talk a little bit about convergence of technology later on, where we are dealing with software-defined radios now that support the Globalstar waveform, and also the NB-IoT and CAD-M1 waveform. The next iteration of that chipset's also it's going to support band N53, which is important to Globalstar because we have a significant portion of band 53 private terrestrial 5G spectrum available for use that's globally coordinated. So think about this from a use case. If you were to embed this module into a piece of machinery or a vehicle or something like that, or onto an asset, then you could have it operate on a base on a private system, roam onto the public system on a cellular base when it was a cellular system when it was available, and then deployed in the middle of nowhere would roam onto a satellite system all in the same chipset. So think about that kind of connectivity, because what we're finding in the marketplace, certainly on the commercial side and certainly on the defense side, is connectivity is not a nice thing to have, it's a must to have, and people are becoming demanding of it. So both of those operate on our network, the kind of the OEM side on the chipset side, and then obviously into the finished products. Why is Globalstar a little bit different than what other products are out there? I talked about it earlier on. There is no registration or synchronization on the satellite itself. We operate the 24 bird constellation, as Henry mentioned, that is a bent pipe technology. So bent pipe goes from user terminal to the sky to one of our 28 ground stations around the world. Those ground stations are typically outside of conflict zones. And because it is a mirror in the sky, you see more than one satellite with your data virtually all the time on the Globalstar network. So we process a lot of redundant data because it goes up to the sky and hits multiple ground targets at the same time. We process on a first in, first out basis, so that if there is localized interference in any particular region, we tend to get our messages through because we have satellites that are located outside of that region and ground stations that are located outside of that region. The devices are very compact and very, very power efficient, which really leads to the ability to have battery operated devices, portable devices, throwaway devices, because of the fact that both the hardware and the technology is quite inexpensive. And then it just makes it very reliable and highly available. The architecture is low latency. We have a lot of redundancy. We have path diversity on the satellite side of things. And of course, global coverage from a landmass perspective. And we do give the ability to support encryption because we don't do any sort of over-the-air decryption, right? Everything is sent in its raw format at both ends. And if you have the keys to the kingdom on the way in, you need the keys to the kingdom on the way out to decode that kind of data. And that's really kind of one of the differentiators that we see in our space, which is why we are being, inundated with, particularly on the single-use drone side of the business right now, with increased inquiries, more people wanting to do integrations, and I've seen quite a bit of success in that in recent times.
Hey, Mark, let me go
Yeah.
on that just for a second.
Sure.
Let me go back to the fourth ID again. What I didn't say the last time about the Joint Modernization Command planning effort for Project Convergence 6 was that there was also a next generation command and control planning session that's also happening. That the Army's #1 command and control program, based out of Aberdeen Proving Grounds, is marching ahead. It's a fully funded program, and it is the highest priority within the Army in terms of communications. A lot of technology you talked about could, may, should have a play in that particular arena. They are changing the way they're fighting. No longer are there tactical command posts that are small cities in the middle of a battlefield. That happens, they're gone. I mean, that's the reality of it these days. So dispersed communications amongst your a maneuver force is going to be very important, and having redundant tracking capability um, is going to be very key. And redundancy is just going to be key to survival on the battlefield. Again, if you can be seen or on the battlefield, you're gonna face some heavy weapons coming in from the bad guys. So just to survive, this technology does have a role in it. And it has to be coupled with other technologies. There's no doubt about it. I mean, there's some limitations with it with respect to that, but to have a choice on the battlefield, the weapon systems, to go to an alternate means, your technology certainly would play well in that arena. So back to you, Marty and Henry.
Thank you.
Makes a lot of sense. We definitely, Marty mentioned this, the proliferation, like just having a sheer number of devices that could be deployed at one time, right? Instead of just one monolithic kind of construct. To your point, Gina, this idea of having many devices to provide more intelligence, more reliable communications, and those kinds of things makes a lot of sense.
And it really comes down to safety too, Henry. I mean, the more electronic, inexpensive devices that get put in the marketplace, and I think that what we have seen in the Eastern Europe and in certainly in recent times is that, if you can do what you can do with a machine and you can do it effectively, it's much better than doing it with a human. So,
Yep. That's a mantra we're hearing quite a bit from the Department of Defense.
yep.
For sure. All right, well, let me shift gears here a little bit so we can sort of start talk a little bit about sort of where things are headed, or maybe topics that are relevant or of interest in the DoD, DOW. Marty, can you just talk a little bit about how non-terrestrial network, NTN, and maybe some other things of interest from a future perspective?
Sure.
Yeah.
Sure. I think it's pretty obvious to everybody who pays any attention to the communication space nowadays that there's a very, very serious convergence happening between the terrestrial and the satellite side of the business. And that's being driven by consumers, being driven by industry, being driven by defense, to be able to have a device that is autonomous to networks. And I mentioned earlier on that people just demand connectivity now. It's not something that is a nice to have anymore. And they're really driving a lot of the innovations. And there's a group based out of Europe called the 3GPP Consortium, and this is where they develop standards, and standards are what drives mass adoption in a marketplace, right? So if you can get everybody to agree to a set of standards, then you get multiple manufacturers manufacturing products, you get multiple networks that can then support those standards, and ultimately get to a place where the stuff is very inexpensive and just autonomously operates across different networks. So there is a big challenge with the 3GPP standards. So they operate in a release situation. Release 17 brought into play the low Earth orbit satellites. I think release 14 was the geostationary satellites, and I think we're on release 19 or release 20. So we're dealing with a set of standards that the goalposts are still moving, right? So what we tend to do and have been doing at Globalstar is that we are watching very closely the emergence of these 3GPP standards. And we're watching them because the standards tend to be very device centric, and device centric standards don't necessarily take into account or care about being very efficient on the network, right? So we're a network provider, so efficiency on our network is very, very important. We want to maximize the finite bandwidth that all networks have. We only have so many frequencies and we only have so much capacity. And standards tend to not be so network friendly. But we're also looking at this from a commercial perspective as well. Direct device is nothing new. We have been doing directed device with our partner for a number of years now. And you'll hear lots of commercials and see lots of commercials on the TV with some competitive broadband satellite systems and their partnerships that are going on. The challenge that everybody's going to have in the long run is that all of these satellite networks speak different languages. They do not share a common core technology. We're very different than our closest competitors in the LEO world, which are very different than the competitors in the GEO world. And to be able to come up with one universal sort of technology that's going to roam across everybody is still quite far into the distance, I believe, if I were a betting person. And you can see that because everybody sort of hitched their wagon to one particular carrier or not, right? So they've chosen a particular partnership. You've got a carrier that's gone and chosen a partnership here, and somebody else has gone and chosen somebody else. So we've got all these kind of competing direct-to-device things in the marketplace. And where the winner will be when the commercial discussions start happening. So there isn't a lot of commercial discussions going on about how everybody makes money at this. And I kind of equate it to the very early days of cellular roaming. For anybody that did a lot of global traveling in the early days, your cellular phone worked great at home. You'd get on a plane, you'd go across the sea, and you'd get off the plane in the other side, and you'd be climbing a light post with your phone in the air saying, "Can you hear me now?" Because whoever the roaming partner was didn't have great service in that particular region. So I think there's a lot of discussion that has to continue on. We're all sort of participants in this 3GPP standards driving this discussion. I think we're a few years away from the goalposts actually fixating to become a mass market technology. But ultimately, I think that's the goal, ultimately, to have this common core technology that will literally just roam across every available network and just choose the best one for everybody and give you that truly ubiquitous coverage, as we talk about, that's available in the world today.
All right, thank you. So I wanted to ask you, Gino, a couple of specific things to get the juices flowing. What are some things that the Department of Defense and industry, what do they do to promote insertion and adoption of commercial capabilities from your perspective?
Well, did a little research on this. I've been talking about this for a little while. Anyway, and that's the adoption of what appears to be a commercial solution into a DoD space. It's a cultural thing, and President Trump signed an executive order back on April 23rd about seeking federal agencies seeking commercial solutions whenever possible and mandating their use. Well, it does several things. It changes the mindset. Before, DoD and other federal agencies used to write their own software, and they had an army of folks doing that. Now that workforce is hollowed out a bit because of all the transitions to civilian life or off the payroll through early retirements and exit bonuses and such. The workforce is just not there. So there are commercial solutions out there, and certainly, the narrowband solution and application is a commercial, ready to use type of uh, capability that DoD has to wrap their arms around. And part of it is to actually use it in either exercises or put it on systems that we know work in other battlefields and observe it. And I think we've done that, and capturing those lessons learned and applying them back to our own systems. So it's a paradigm shift in the way we think and how we develop systems and acquire capabilities. The commercial sector has a lot of solutions. Can they be adapted to military use? Yes. And this is one area that is ripe for it. Marty's been talking about it here this morning or this afternoon in great detail. It's a technology it's mature, TR9, TR level 9 or more. It's something that we haven't fully leveraged yet. Anyhow, but in my mind, it's a cultural thing, and it's just a matter of getting people to stop doing what they've been doing for the last 2 decades, and, and now embracing something a little bit different. And that's not easy to do sometimes.
Right, right. Yeah, and I think that, this idea that that our military, they definitely see benefits in the approach, and seeing that they're actually putting money behind the shift does help quite a bit, because funding obviously will be needed. But yeah, there's a lot of ways that the Department of Defense has tried to integrate, commercial stuff into their environment, CBERs and OTAs and CRADAs and all the things that enable commercial companies to get on board. But yeah. Let me ask you something else, Gino. What are the current tactical and technical challenges that are being observed with respect to high priority mission sets?
Okay. It is the pace of change. Um, and one of the biggest things that we're going to have a different, our modernization strategy in terms of Department of War is going to have to embrace on a tactical level capabilities that are are pretty fresh to a lot of users. And we're talking the young ones, young folks that are behind, that are in there will adapt very quickly because they don't know anything different at this point in their lives. But the mid-level NCOs and senior NCOs will have to learn to embrace this technology. It's going to be very uncomfortable for them. But
Mm.
if they don't embrace it, it's a matter of survival. They don't really have too much of a choice. So that'll be a catalyst to do it when they look at lessons learned and from Israel, Ukraine, and other places around the world where technology has played a role and the pace of innovation has played a role. When you look at Ukraine and Russia, it's a race of who can out innovate the other the fastest. And we're sitting on the sidelines right now today with a force that's attempting to just now starting to do that. How fast can we innovate? And does that mean we're going to have different brigades in our force structure, deployable with different capabilities at different points in time? Yeah, it's going to be a lot of different brigades, each with a different set of capabilities going into a particular fight, because that's the pace of change. And in order to give them the best capabilities that technology can offer at the time, and the fastest, you can only buy a small set. It goes back to funding and all that business. But
Mm.
once you get the technology, you got to train. You got to rehearse with it. You've got to get comfortable with it, and you got to be able to use it with confidence. And
Mm.
all those things have to come into play. And the Fourth Infantry Division, apologies for bringing them up, but they're designed. Their mission is to take technology and do just what I just explained.
Mm.
So, and it's going to be rolled out to other divisions, other combat brigades, Marine Corps, Air Force as appropriate, and the Navy as appropriate in terms of a ground role piece of this. Space Force is going to be across all of that in terms of support. And this is where narrowband will have a role and will have a significant role in the future. It's just a matter of getting comfortable to the technology and the application.
Mm. Yeah, it really sounds like all the services need to look at, how they're hiring, who they're recruiting, with kind of this in mind in a way. Yeah, so
Well, cyber in the cyber arena, they've been grappling with that a long time, so it's not totally foreign to them. Uh, they have to find folks that are technology savvy, if you will, and
mm,
uh, it's going to come naturally, particularly when they get lay their hands on this technology and use it. So it's not a war game anymore. It's not a video game anymore. This is real stuff.
Right.
And there's real consequences as a result of it both ways. So that's going to be, frankly, that's going to be appealing to a lot of people. Oh,
Yeah. Okay. Good deal. So I think I'm going to sort of wrap things up with we'll move into a Q&A, but before we get into Q&A, I just have a couple of one closing question for both of you. Maybe you first, Marty, with your experience in the industry, what kind of predictions for this space? Where are things moving from your
Oh,
perspective?
that's a tough question to answer, Henry. I would say that it's moving rapidly in many different directions almost at the same time. And I think ultimately what will happen is we will converge somewhere down the road with a set of standards, first of all, that everybody will sort of conform to. So we'll have some commonality between networks in the sky and on the ground,
Mm.
which will enable kind of that seamless flow between terrestrial and satellite, that the promise of NTN has given us. But I think we'll also see smaller, simpler, more connected devices than ever before. And when I say connected devices, you're talking everything has a connection. So you will have the ability to monitor, whether the door is open in your car or whether the light is left on or whether the tire pressure in your car is 5 kilopascals lower than it should be. And I think what you're going to get is you're going to get this kind of visibility like no one can even imagine. So you're going to have this, and it's going to require some real innovation on the processing side of that data to be able to sift through all of these connection points that are going to come into view or review, and we're going to have to be making some pretty significant use of AI to make some more decisions and analyze that stuff quickly to be able to give you instant access, well thought out computer speed thinking, and suggested actions based on that connected everything out there. So I think that's where it'll go eventually. Yeah, we'll probably have little communicators on our chest and things like that to talk to each other as well. But somewhere along the way, I think that's where it's headed.
All right. I knew AI would be thrown in here somewhere.
It certainly is. I'm simply amazed at the amount of information that you can glean out of a very simple question using an off the shelf bot, so to speak. So
Right. Very cool. How about you, Gina? What's, with your context, what are your predictions for this space moving forward?
well, it's going to be interesting from the standpoint of the adoption piece. Who can adopt it, and why are they adopting it? Is very important to understand that.
Mm.
When you have a capability like this technology offers, I'm not sure that we've fully discovered all its applications and uses. And there's going to be a lot of innovation as a result of that. I mean, that's what technology evolution that we've seen is all about. I mean, we're at this state now where we've seen a different way of warfare, and my goodness, it's not only entertaining, it's frightening, and it's from that standpoint. And okay, we're going to see technology applied in to find solutions and to take the fight to the bad guys, and that's what we're going to do. And believe it or not, I mentioned video games earlier. It's actually a great training for our young folks. They have the mindset. If I do this in a virtual environment, I can rehearse an operation using this technology. And operation rehearsals are very important because they allow you to make mistakes without any consequences. And that's huge. And
Yep.
once you fix those things and make the operation a higher probability of success, then you really have something going on here. And it's a lot of training, a lot of simulation, a lot of mission rehearsal. Uh, And this technology has a role in all of it.
Yeah, that's right. You know, rehearsal and then post-processing. Like, okay,
Roger.
what did I do right? What did I do wrong? Right? That kind of thing. So, all right. Well, very good. We'll wrap up the fixed question period. We'll move into Q&A. We've got a few questions here that have been posted. Let me just look them over here. So, Marty, let me send this one to you first. Have you noticed any energy power bottlenecks when computing large amounts of data at the edge?
Yeah, so I would say yes. Obviously, you know, computing power does take a lot of energy. So it doesn't fit. I would say it doesn't affect us so much because obviously we're computing smaller amounts of data than you would think from a large edge type environment because we have to get it down to a format that we can send over the air. You know, from a decision making perspective. But obviously in our world, because we tend to be completely power autonomous, energy, power usages, battery capacities, they influence everything we do on a daily basis.
Yeah, and I would say, you know, the benefit of sort of narrow band is you're giving you know, since we're not consuming as much power, you can use more power in the compute. So, yeah. Okay, very good. And I'm not sure, Gino, this question came up. I'm thinking you may be able to field it. Let me just say it and then you let me know. What should the Air Force do as an air component to best integrate our Air Force Space Force systems to Project Convergence and Joint All Domain C2?
Well, I think participating in the process of planning for a Joint Convergence 6, the next big exercise, they're an annual exercise that has a specific vetting process for technologies. Um, as far as the Air Force and Navy, I think they have their own vetting process. I know I'm familiar with the Army because I'm Army. So uh, the vetting process for a lot of the ground technology goes through Aberdeen Improving Ground and C5ISR folks. And it's bench tested there. And as long as it can connect to the network at home station, that saves a lot of problems when they get downrange and get ready to do the exercise. They don't spend a whole lot of time trying to connect to the network, and it eats up a lot of available time when it doesn't. So pre-vetting the technologies would be my recommendation to the Air Force and Navy in terms of connecting with the Space Force integration as well. And take a look at their weapon systems. I know a lot of their weapon systems on board have redundant systems in case of jamming, and they can do other things to get to the business end of their weapon systems and ensure a successful launch or successful targeting or anything of that nature. So testing out the technology in different forms and different environments is important, and they can do that in their specific environments to find where the gaps are. And finding what the gaps are going to be important because we got to solve them. Because we see a gap, our adversaries can see gaps.
Makes sense. Okay, we'll move on. The next couple of questions are really kind of security related, Marty, and Gino, feel free to jump in after maybe if you've got thoughts on cybersecurity. But for space-based capabilities, do commercial solutions and services have the ability to meet military cybersecurity requirements? Marty?
So I think a general answer is that the off-the-shelf commercial solutions we have today do not support the military cybersecurity requirements. But because we are in many cases just a data transfer We also have the ability to bring in external data sources. And as such, we can be the transport mechanism of something I call kind of pre-encryption. So you encrypt something before it gets to us, and we simply carry it over the air, and you decrypt it at the other end. From an infrastructure perspective and an IT requirement, all that sort of stuff, that's not really my expertise. So I have a little trouble commenting too much on that at Globalstar. I'm very much on the hardware side of things. But certainly we take cybersecurity very seriously at Globalstar, and have a number of ISO certifications. We'd have to look into specific requirements if there were specific ones we would have to comply to.
Okay, thank you. And I've really, we might have time for one or two. Go ahead, Gina. If you have
Just real quick. Cybersecurity, it's an industry challenge, but it's also complementary to DoD. There's a lot of industrial espionage that goes out there, and the same sort of espionage that commercial industry is dealing with, also Department of War has to deal with. So while some appear to be on the surface need to be converted for military use, that's probably true. Not everything, and some are probably more advanced in terms of cybersecurity in this arena than the Department of War assets, depending on where you're looking at it. And then there's also a flip of that is, does the commercial solution for that particular problem need to have all that type of other than the basic cybersecurity stuff, does it have to have all the bells and whistles needed to perform the mission for the Department of War? That needs to be also discussed and addressed at the time of
Yep,
the
absolutely. All right, so let me just, Marty, if you could answer this question in 15 seconds or less, you win. Does Globalstar provide a SATCOM sandbox testing platforms for cyber-funded developers, integrators, e.g. read-only IQ taps, dry run control outputs?
Not really, although we do have test bed locations within our infrastructure that you could get access to without necessarily talking on the network. So we have two facilities that could accommodate something like that for the right person.
Yeah, so we'll follow up with that person, because that might be a part 2 conversation as well. We've got a number of good questions that we can't get to, so we'll have to kind of wrap it up here, and I'll hand it back over to Sam.
Thank you, Henry, and thanks to the panel.